Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Tom Cole, Vice President of Sales and Marketing at Integra Technologies. Welcome back to the show, Tom.
Thanks, Pat. Great to be here as always.
So Integra has their unique high voltage GaN addressing high power pulsed applications. What trends are you seeing in the high power avionics, ISM, and radar markets that you participate in?
Yeah, it's been a really fun year and a half since we rolled the technology out into production with some of our lead customers. The ask has been, how do we get to multi-kilowatt transistor power levels for different applications, including, besides what you've mentioned, the emerging directed energy area for defense applications. And so that really has been the key that we've been asked, and Integra has stepped up as far as the challenge goes. And we're now pushing those transistor powers definitely above that multi-kilowatt level, enabling system architects at all of the different applications to do really interesting things with those in terms of re-architecting systems for size, weight, power, cost, complexity, and everything that they are really targeting year over year.
And so Integra's been supplying the 100-volt RF GaN on silicon carbide for a couple years now. How has that technology matured over that time frame, and how much power are you getting out of a transistor now?
Yeah, it's been a really fun evolution, and I'm happy to say that watching some of our early adopters who went to production here over the last 2 years and started to produce systems with the 100-volt GaN, it's been fun watching them reduce the size of something like believe it or not, a scientific amplifier for particle accelerators, nearly 70% in terms of its volume, because we were able to give them a 400% increase in per transistor power compared to what they were using.
And so with these increases in single transistor powers, what does that mean for the customers? What benefits for systems that they're using, and what do they realize at the system architecture level?
Yeah, so if you look into the nuts and bolts, and we've really brought some interesting talent into Integra, actually CTO level system engineers. We have a distinguished fellow from Lockheed that has joined us. And these folks are really instrumental in educating us on how to help customers re-architect. So what we've seen them do is really be able to go in and replace 2, 4, 6, 8 different power amplifier sections with a single pallet. And that's been key in terms of thinking about reducing the redundant printed circuit board space, the redundant matching circuits. All of that goes away. And so as we got to see some really fun results with a customer, and actually they showed us in their 6-foot rack, half of the rack went away because they were able to replace 4 pallets with 1 or 2. And that allowed them to get rid of all the high power cabling and the redundant combiners and all of these things that do cost you efficiency. So not only does it become simpler, smaller, lighter, and less expensive, that's another one that I will mention, that we've been saving people 30 to 40 to 50% at the system level. So that's the other big benefit that they get aside from the technical advantages and the reduction of complexity.
Yeah, that's quite a size reduction. Very impressive. So we've seen companies like digitizing their products, kind of making them more flexible and smarter. What kind of work are you doing in this area?
And that's a great trend that we have been seeing as well, and have been asked to step up as well. So we have a number of customers ranging from commercial to defense applications who want to be able to command control, and monitor and adjust that amplifier palette. So what Integra has been working on, and what we debuted at European Microwave last year, is our digital palette form factor. So this marries up our high voltage GaN technology with a digitally controllable interface, and that allows them to do very exciting things with artificial intelligence, where they may sample what's coming back from a radar, and they would adjust the amplifier to get a better resolution on that radar, depending on the type of return they were seeing and the physics of what type of pulse best detects an object. And there's very similar applications for directed energy and for defensive applications like that that guard against airborne threats like drones. And so all of these things are something we want our customer base to be able to have the ability to take advantage of that machine learning and allow that to direct the amplifier palettes that we produce with our high voltage GaN to meet whatever that objective is for that particular program.
Well, thanks, Tom, for talking with me today about Integra's Technologies, high voltage GaN and digitization efforts. I know we'll have you back, I think, again in the fall to give us an update on what you've been doing, because there's a lot happening with Integra. Thanks, everybody, for watching, and join us next time on Frequency Matters.